Welcome to the .NET Way. You're watching episode 15 of our .NET Core interview series. Today, we are going hands-on with something every backend developer should know: writing real integration tests using Entity Framework Core. Let's ask Arohi how she sets it up and avoids common pitfalls. Arohi, what are we really testing when we write an integration test with EF Core?
We test how our application components, like repositories and our business logic, interact with the actual database. Unlike unit tests, these tests use a real or simulated database and help catch issues like broken link queries, missing relationships, or incorrect entity mappings.
What do you prefer for these tests? A real database or an in-memory one?
For fast, lightweight tests, I use the EF Core in-memory provider or SQLite in in-memory mode. But for a more accurate simulation of production, I use test containers to spin up a local SQL server. SQLite is usually my middle ground because it supports relational constraints, unlike EF's default in-memory provider.
Can you show us a basic setup of how you configure the context for a test?
Sure. As you can see on the screen, I override the DB context options during the test setup phase. I tell the builder to use an in-memory database and give it a specific name. Once those options are built, I pass them into my application DB context, and then I can use that context to seed data and run my tests.
Walk us through what a real integration test actually looks like.
Let's look at the snippet on screen where we test a getUserById method. Notice that we use two separate using blocks. In the first block, we use the context to insert a dummy user into our test database and save the changes. In the second block, we create a fresh instance of the context, pass it to our repository, and verify that it can successfully retrieve that user.
What's your strategy for cleaning up the database between tests so data doesn't overlap?
It's crucial to keep tests isolated. First, I use unique database names for every single test. Second, if I am using SQLite or a real SQL database, I make sure to run the ensureDeleted method inside the test's dispose block or cleanup method. This guarantees the database is wiped clean before the next test runs.
What if you're testing entities that have foreign keys, like a user with a list of orders?
You have to ensure Entity Framework is properly loading that related data. I write the test to call my repository, and then, as shown on screen, I assert not just the primary user data, but I also write assertions against the navigation properties, checking that the orders list is not null and contains the expected data.
How do you make sure your tests are reliable and aren't passing by accident?
The biggest rule is using fresh database instances for every test. If you reuse data, a test might pass just because data from a previous test was left behind. Also, ensure all your asynchronous code is properly awaited and use meaningful assertions. Don't just check if a result is not null, check if the actual properties match your expectations.
Are these database tests able to run automatically in GitHub Actions or Azure DevOps?
Yes. As you can see in the command on screen, I run my integration tests in the CI pipeline using a category filter. If my tests require a real SQL server or PostgreSQL, I configure the pipeline to spin up Docker containers using test containers before the .NET test command runs.
Can integration tests go beyond just testing Entity Framework?
Absolutely. I use the WebApplicationFactory class to test real HTTP requests and responses against my test database. This gives us full API-level test coverage. It proves that the API routing, the model binding, and the Entity Framework data access all work together perfectly.
Where do you draw the line? Do you write an integration test for every single method?
No, I don't test everything. I only write integration tests for critical paths, like user login, processing an order, or complex data updates. Most of my business logic stays in unit tests because they are faster. Integration tests just cover the glue and the database behavior. Balance is key.
I see junior developers using MOQ to create fake DbSets. Is that a good practice?
No, that is widely considered an anti-pattern. Mocking a DbSet or iQueryable is incredibly complex and fragile. It doesn't actually test if your LinQ queries can be translated into valid SQL. Instead of mocking the DB context, you should always use the InMemory provider or SQLite.
You mentioned the InMemory provider earlier. Are there any risks to using it?
Yes, the biggest danger is that the InMemory provider does not enforce relational constraints. For example, it won't throw an exception if you violate a foreign key or save a null value to a required column. If you need to test actual database constraints, you must use SQLite or a real SQL database.
So if I want to test that my database throws an error when a duplicate email is registered, how do I do that?
First, you configure your test DB context to use SQLite. Then, you insert a user and try to insert a second user with the same email. As shown on the screen, you wrap the save operation inside an assert.throws async block, specifically looking for a DbUpdateException. This proves Entity Framework correctly blocked the duplicate insert.
When you use a real test database, do you run migrations before the tests execute?
Usually, no. Running traditional migrations can be very slow in a test suite. Instead, look at the code on screen. In our test setup, we use the ensureCreated method. This bypasses migrations entirely and directly builds the exact table schema based on your current DB context model. It is much faster for testing.
Typing out dozens of test users with fake names and emails takes forever. How do you speed that up?
I use a fantastic NuGet package called Bogus. It allows you to generate thousands of realistic records, like random names, valid emails, and addresses, using fluent syntax. It saves hours of typing and ensures your tests have varied realistic data.
Many apps use soft deletes, where they just flag a record as deleted and rely on EF Core global query filters to hide them. How do you test that?
You insert two records into the test database, one active and one marked as deleted. Then you call your standard getAll method and assert that only one record is returned. To verify the deleted data is still there, you can use the ignoreQueryFilters method shown on screen and assert that it successfully retrieves both records.
If a service method uses a transaction to save multiple things at once, how do you test that a rollback works?
You simulate a failure. You create a test where the first insert succeeds, but you purposefully pass bad data for the second insert so it throws an exception. Then, in your assertions, you query the database to verify that the first insert was successfully rolled back and does not exist in the database.
If an integration test fails, how do you see the actual SQL that Entity Framework tried to execute?
When configuring the DB context options in your test, you can chain the log2 method, passing in console.writeLine as shown on screen. This will print every single SQL query directly into your test runner's output window. It is incredibly helpful for debugging why a LinQ query failed or why it is running too slowly.
Repository calls a stored procedure or uses raw SQL. Can you test that?
Not with the InMemory provider, because it doesn't understand SQL syntax. To test raw SQL or stored procedures, you must use a real relational database. I usually rely on test containers for this. You create the stored procedure in your test setup script and then assert the results just like a normal EF Core query.
Last question. How do you test what happens when two users try to edit the same record at the same time?
You simulate it by creating two separate instances of the DB context in your test. Both contexts load the exact same entity. Context A updates it and saves changes. Then context B updates it and tries to save changes. You then assert that context B throws the DbUpdateException shown on screen.
Excellent explanation, Arohi. This was a hands-on look at real integration testing, not just theory. If you're building production-ready APIs, mastering EF core testing is a must-have skill. If you liked this episode, give it a thumbs up, drop a comment, and subscribe to the .NET Way. In episode 16, we'll talk about async and await in .NET Core and where developers often go wrong. Thanks for watching. See you in the next one.